Hello friends, welcome to Greedypi. I am Arham Doshi and let's get started. So in this week we'll start with the algorithms of sorting. So what is sorting? Sorting is basically ordering elements in either increasing or decreasing manner. Like given an element, you need to give an particular order to them. So the first resource I would like to suggest is this sorting playlist of my code. So another thing would be like go through the algorithms page of Hacker Earth, and it is having like tutorials and problems, and you can like watch this tutorial, go through them once. There is one question at the end of this tutorial. Just go through it and try to solve it.
So let's discuss this problem. In this, you are given an array and you have to find if it has two or more equal elements or not. So, like, say there is some array 5, 3, 1, 2. In this, you can say that there are no equal elements. And like, if an array is something like that 1, 3, 1, 2, and in this, you can see that there are two ones. So, how can you solve it? So, we can just sort this array, and if there were any equal pairs they will occur adjacently, so we can just compare adjacent pairs. Here we'll compare like these two pairs and these two, and we'll get to know that these both are equal. So when talking about sorting, there are like two types of algorithm. One is based on comparisons and one is not based on comparisons. So these are like follows. There is like bubble sort, selection sort, insertion sort, merge sort, and quick sort. And like in non-comparison based sorting, we have like counting sort. And further like classifying algorithm, these three algorithms are like iterative algorithms, and these two are recursive algorithms. So now you are given an array and you are asked to sort this array. So how can you do it? So the most simplest approach would be to use bubble sort. In that, what we do is we like use nested loops. In each loop we'll try to compare two adjacent elements, and if the element at like I plus 1th index would be like greater than less than ith index, then we can like swap this. Okay, so here we will notice that there we won't require any swapping, but at this position this condition will hold true and we will like swap this. Okay, so now 10 is here and 1 is here. Again, this condition will hold true and we can like swap this. So now 10 is here, 2 is here, and again the same condition will hold, and we'll get something like that. And after one iteration, we'll get an array something like that. So what is happening is like 10 is been like, as the bubble comes above the water, the greater elements will go up and up and up in the array. And like after running this algorithm for n times, we'll get a sorted array. So the complexity of this algorithm would be n square, because in one iteration we are comparing all the elements that are like n elements using n minus 1 comparison, and we are doing it for like n times. So it would be n into n minus 1 swaps, that is like n square swaps. And we can solve this also by using like insertion sort or like selection sort. You can see learn about them from resources. Okay, so how can we improve this n square complexity? So to improve this complexity and to go from n square complexity to n log n, we'll have to solve it by using something called recursive algorithm. And one of the recursive algorithm is like merge sort. So what does merge sort will do is merge will recursively first break the array into smaller parts until only one element is left, and it will like try to combine this into array that is like sorted. If the length of an array is n, we'll like divide the array into smaller parts, would be like that would be like n by 2 size, then it would be like n by 4 size, and at last we'll reach the size 1, and then we'll like go back combining the sorted array. It is a recursive algorithm. So the height of the recursion tree would be log n. For each recursion, we will be combining all the elements in of n. So the combined complexity would be like n log n. And in one and in each recursive step, we will be combining two arrays in of n. So the total time complexity would be like n log n. So if we take this array and try to run merge sort on it, it would be something like this. So at first we'll try to break the array into like almost equal parts, and we'll do this until the size of the elements of the array is like 1, and after that we can like combine those array. They both are like sorted array, and that can be combined in of n, and like we'll try to combine them recursively, and after at the end we'll get the sorted array. So now let's discuss if we can like further improve the complexity of this n log n. We cannot improve it for comparison based algorithms theoretically, but we can use some algorithm that won't depend on this comparison. One such algorithm is counting sort. In this, what we'll be doing is we'll try to make a bookkeeping array which will store the frequency of that element. Okay, so the ith index will store the frequency of element I. Okay, so for our case, uh, the array would look something like this. So we can just iterate through the array and print the element the number of times its frequency is. So we can like first print 1, then we'll go to 2. We'll see the frequency of 2 is like 1. So we'll print 2. We'll go to 3, 4, 5. We'll print 5. We'll print 6, and then we'll go to 10 and we'll like print 10. So it would run in of n times, but the thing is it is not O of n. So the catch here is we have to iterate through all the elements from 1 to m. So this is will also imply some complexity. So the final complexity would be like of n plus m, where n is the number of uh, elements in the array, and m is the maximum element of the array. Another important topic is inversions. Inversions is nothing but pairs of indices that are in wrong order. Okay, so how will we come to know whether a pair of indices is in wrong order? Let's say we have two elements with index I and j, and I is less than j. And if the array, the element at ith index is greater than element at jth index, then we can say that in the sorted array, this is wrong. We have to like swap this. So we can say that this is wrong order. In sorted array, every such I comma j pair should hold this property. Okay. So if it is following this property, we can say that it is an inversion. So in our array, let us try to find the number of inversion. We know that 10 should be like greater than 1, 10 should be greater than 2, and 10 should be greater than 5. So these three are an inversion pairs. We also know that 6 is also should be greater than 1, 2, and 5. And so these three are also an inversion pair. So in our array, we will be having like 6 pairs of inversion. Okay. So if you want to sort an array in C++, you can use this inbuilt sort function. It is in algorithms library. It will uh, take three fields: start, end, and comparator, and this is an optional field, so even if you don't give this, it's okay. So now let us try to sort this array using our sort function. To sort an array, we can write something like this. Like sort v dot begin, v dot end, and it will sort the array. Okay. In an increasing order. So you can see that it has been sorted now. To sort it in decreasing order, we can write sort v dot r begin and r end, where r begin is the reverse iterator which will point to the end of an array, and r end will point to the element just before the array, and it will sort it in decreasing order. So you can see here. And to sort an array, so the above two were for sorting the vector. Now to sort the array, you can write sort the name of array and the size of the array, and it will sort the array. Okay. Okay. Yeah. So we have got the result. So you can like remember these three methods. So now I will be. So now what you can do is you can go through this question of the day. It will like help you to consolidate your learning, and I have uploaded the solutions on the GitHub repo, so you can refer that in case you need help. Okay.